Hey all, welcome back. We are now in chapter 9. Seems like we've gone really fast. So today's chapter is beer farms and peas and the use of statistics, and you're going to figure out why it has these three very strange words here in just a second. But let's look at what we're going to look at today. So we're going to explain why we need to sample from a population. We're going to compare basic concepts of descriptive statistics, such as the ones we've already used: mean, median, range, mode. We're going to add two additional today. One is variance and the other one is standard deviation. We are going to use histograms to explain the concepts of central tendency and measures of dispersion. We're going to understand and be able to generate a normal distribution when we look at those histograms. And finally, we're going to demonstrate how to use the following R functions. We're going to use our mean, median, variation, standard deviation, hist, and R norm. So let's get started. We always have to start back at the beginning, so let's look back into the 1900s, okay? That's when mathematics was born. At that time, people thought any problem could be analyzed using mathematics. Four Englishmen who were on this journey are Francis Galton, Karl Pearson, William Seeley Gosset, and Ronald Fisher. So Francis Galton created the statistical concept of correlation and regression. Okay, he studied heredity in peas, rabbits, and humans. Okay, next we have Karl Pearson, who was actually a junior partner of Francis Galton. So Karl Pearson is credited with founding the actual term and the field of statistics. Gosset, on the other hand, he actually was hired at the brewery, the Guinness Brewery in Dublin, Ireland, which I thought was kind of cool, but who doesn't mix their alcohol with math? And he came up with a way to aid in making the beer more consistent in quality. Okay, this ended up being the small sample statistical technique. Okay, he was taking small samples to predict what was going to happen in the large batches. Last but not least, we have Fisher, Ronald Fisher. Fisher was a farmer, and he pioneered the area of experimental design, including factors and levels, experimental groups, and control groups. So this is where this chapter gets its name from. Okay, you've got beer, farms, and peas. I thought that was kind of interesting. All four of these gentlemen played with the idea of a sample versus the population. There is always more data out there to be found, whether it is on the outskirts, whether it has not been created yet. There's always more data out there. But is that data that's out there going to change the thinking that was proven by your samples? Okay, this is our goal. What we're looking at is just a sample or a snapshot, but is that snapshot good enough? What we do have are techniques and tools to describe the data by generalizing and inferring, meaning to correlate that sample to the population. But we have to remember that there's always uncertainty in that data. And Fisher did help pave the way for characterizing and quantifying that uncertainty. So this is the main difference between descriptive statistics versus inferential statistics, okay? Your descriptive statistics is going to be that describing of the data. Inferential statistics is going to infer that meaning using the generalizations. What we're going to look at today is descriptive. So we've used these common descriptive statistics. We've used mean, which is the calculated average, median, which is halfway in a list that has been sorted. Range is a measure of dispersion or how spread out the numbers are, and mode, which is the value occurring most often. So mean, median, and mode are all descriptors of the central tendency, whereas again range is a measure of dispersion. So we're going to add two more descriptive statistics into our toolbox, and we're going to add variance and standard deviation. So let's take a look at those. First, we're going to look at variance. Variance is a measure of how spread out the sample is. So it's a measure of dispersion, just as in range. but it's going to use a calculation comparing each number to the mean. We're going to take a deep dive into this calculation here in just a second. So it's going to take the distance away from the mean and square that, okay? That number is then going to be divided by the number of samples or the number of observations, and it's this calculation and it's distance from the mean that sets it apart from the range, whereas range is just your max and min, right? So let's take a close look at an example of what this looks like. Here's the list of family members we used a few weeks back. So this shows that the mean age of all of the family members is 22. The first calculation, which is the third column over, this one right here, okay, is going to be the mean subtracted from the age of the family member. Notice you do have positive numbers and you've got negative numbers, and all that's showing is which side of the mean that those values are falling on, right? Your positive is going to be above the mean, your negative is going to be below the mean. Then this last column here is just taking this difference and squaring it, which gets rid of the sign, and it's great. So we're going to add that column up here and then divide by 4. 5 minus 1. Now it says here that the variance is 356.5 squared years. I mean, what does that mean? It doesn't mean anything to me. So what we're going to do is we're going to take this variance, we're going to take it one step further to actually give it a little bit more meaning. Okay, what we're going to do is we're going to create the standard deviation to try to make some sense out of what this is. Now, the standard deviation in its most basic form is the square root of the variance. Okay, this puts us back into years, because remember we were at years squared. This puts us back into years, gives us a little bit more headspace to understand what's going on. So let's take a look at this using R.
I've opened up my RStudio and I've actually created a script to create the data frame that we had used back in chapter 5. So I'm going to go ahead and just save this before I forget. Save as family data. Okay. And I ran my script. So now I have my data frame in here. You can see over here on the right with RStudio my family, and it's got all the information. Now, what we really want to do is we want to look at the variance and standard deviation that we were just speaking of. So in order to do variance, it's the command, oops, wrong window. I can just come down here at the bottom and I can say variance and put a parenthesis. Now I can send it family and then send it let's send it ages, because that's a nice numeric right here, okay? So we can say var my family $sign to indicate the column, and then my family ages. So there's that variance that we saw in the table just a minute ago, the 356.5 squared years. So again, this doesn't make a whole lot of sense to my brain, so let's go ahead and look at the standard deviation. Again, the command is just SD, and then you want to send it your list, my family $sign. And the nice thing about R is that it does bring up, things, because I'm lazy. I don't like to type everything again. So hence the script for family data. And I could, so I can ask for the standard deviation. Now the standard deviation is 18 years. That makes a lot more sense. Now, the other way that you can use the var and standard deviation is if you have, you can actually send it a list that you create within the command of the variance. So let's say 43, let's use the one in the book, 42, 12, 8, and 5. Okay, it's the same numbers as the ages, and I can go over here and it's going to give me that same number. The same actually is true for the standard deviation. I can send it a list that I'm combining on the fly. So let's see if I can type these numbers correctly again. 12, 8, and 5. And I get the same answer. The only difference between these two sets of code is that one is using the data from chapter 5 in an already created data frame, And the second is just using a list straight out. Other than that, it's exactly the same.
Okay, that was fun. But let's take this back into that US population sample that we had last week. That was like real good data. What I want us to do, we're going to create a new function. We're going to call it read census. Okay, what that's going to do is do all of those steps that we did during the data munging, and it's going to read the data in, it's going to clean it up and give us useful data. That way we can use it in the future. Okay, we know it works. We know what kind of data we're going to get, and if we ever want to go ahead and use this census information again, we can just call that function. We're also going to put some notes into this function so that we know exactly what we're doing, and later on when we look at it, we have a better idea. So to add a comment or a note, what you're going to use is the hashtag or pound sign. They're both the same. It's above the number 3. And basically R just ignores everything that comes after that. So we're going to use a lot of those to comment our function. We're going to save it as its own file. We're also going to create a function called numberize. And this is going to take that one step that we had that we were doing a lot of converting the numbers and getting rid of all those extra characters and symbols and stuff that it had. We're going to create a function to do that because we seem to be doing that a lot and there was a lot of typing involved and I don't want to do that. So we're going to create it into a function. So it's going to be great. Okay, so let's combine the last couple of lectures and let's make some functions.
Okay, I've got my RStudio open and ready to go. File, new R script. Let's go ahead and say save as, and let's call it readcensus.r. Yeah, I'm going to replace it because I had one before. Okay, now the first thing we're going to do is create that read census function. So read in the census data set. Okay, just a comment. Read census assignment statement is going to be a function with nothing sent to it. So open and close. We're going to put our open and close brackets and we're going to start our function. Now what we want to do is take all of that information that we did from chapter 6, the data munging chapter, okay? So if you have all of that code, you can copy and paste. I don't know where I put it because, you know, I'm so organized. URL to read. We're going to store in it a string, and I'm going to copy the string because I want to make sure that I type it correctly. There we go. Okay. Now we're going to read the data from the web. And to do that, we're going to create a test frame. We're going to assign to it read.csv. Okay, we're going to use that function again. We have to tell it that we're sending it a URL and we're going to send it URL to read. Okay. Now, let's get to that data munging part. So we're going to remove the first 8 rows, which was that header information. So test frame, store inside of it test frame. And as a review, square brackets, and we want rows, so rows come before the comma. And to delete, we use a minus. Okay? So that now let's only keep the first 5 columns. So we're going to say test frame, store in it test frame, square brackets, comma. Columns are to the right of the comma, so let's leave it there. And we're going to keep 1 through 5. Okay, you can do it one of 2 ways. You can do delete the 6 through 10 and or whatever you want to do it. Let's keep 1 through 5. Now let's rename the first column. Okay, so test frame, let's create a column, say state name from assignment test frame, and we want it from column 1. Okay. Now let's get rid of the existing one called state name. So test frame, we're going to store in it test frame, and we're going to delete the first column, so comma, -1. Okay. Next, we're going to remove the tail information from the end. Oops. There we go. Test frame. Let's store in it the square brackets. Let's get rid of, I believe it was 52 to 58 rows, so it's before the comma. Now, let's clean up some of that data. So let's say test frame, state name. Okay, remember for that we use the G sub, the global substitution. We need to do the slashes, right, to make sure that we are talking about the actual physical dot and not a command dot. We want to replace it with nothing. And we want to go through that column. Okay. Last, well, not quite last, almost last. Let's clean up the columns now. So convert the columns to numeric and rename. Okay. Now this is where we want to create that function called numberize. So let's see. Oops, test frame, April 10 census. Okay. We want to be able to say numberize and just send it X. Okay. We don't have numberize yet, so let's go outside of the curly brackets and let's create numberize. So numberize is a function. It's going to take an input vector. Okay, put our curly brackets so that we know what it is. Now, what we're going to do first, let's get rid of commas. Okay, so it's going to be very similar to this line. So I'm going to go ahead and copy and paste. Except here, we're going to say input vector, G sub. We're going to get rid of the commas. So we're going to change that period to a comma, and we're going to call this input vector. Oops, if I can spell right. Okay. Now we want to get rid of spaces. So that is actually going to be this line 31. Almost identical, right? Because what we want, actually we don't need them there. What we want here is just a space, okay? And that's going to get rid of the spaces. Now we want to convert to number and return. So we're going to say return as, right? Because remember, as turns it back to the number, so as numeric, okay? And what we want to send it is input vector. That is going to return the vector as a numeric, okay? So let's go back up here. So we've got 1. Now we have to do the other 3. So let's copy 1, 2, 3. Okay. April 10. Oops, that's not what I wanted to do. April 10 base is the next, and that is x.1. This is going to be July 10 population. That's going to be x2. This is going to be July 11 pop, and that's going to be x3. Okay. Now, let's get rid of the x, the x1, x2, x3. So test frame, assign to it test frame. We want columns, so comma comes first, and we want to get rid of 1 through 4. Okay. Last but not least, we want to remove the row, the old row numbers, names. Okay, because remember we deleted some rows, so it now starts at 9 if you remember back to that data munging. So row names, if I could spell, test frame. We're going to make them null, all caps, and then we're going to return the test frame. Okay. saved it as read census. I'm going to go ahead and hit the save button here. You can see it created some functions. Okay, so let's come back to our console here, and let's see if we can US state populations. Let's save it, read census. Okay, let's see what happens. Okay, you can see up here in the environment we have a new data. It is US state pops. So that went into our function and did exactly what we were hoping it to do. So to verify, let's look at US state pops, and let's say April census. There we go. And let's look at 1 to 3. Okay, there are values, the first 3 values. Now, we can do some additional manipulation on this. We can say the mean of the US state pops, $, April 10 census. Sounds good. Okay, we can do the median. There's no A in median. There we go. We can do the mode. Okay. We can do the variance. And then finally, we can do the standard deviation. Okay. There you go. There's using some data to go through our new descriptive statistics.
Having that descriptive statistical information in numeric form is good, but having it in a graphical form is even better, right? Everyone loves pictures. So let's make a histogram. A histogram is just a pictorial representation of the data showing the dispersion. It's usually a bar graph. It's going to show where the data falls, and it's a really good tool to kind of show the overall picture of what's going on in the data. So the command in R to show a histogram is just HIST, and then you send it to the list, okay? So in the census example, we can send it a column from that data frame. So in this example that we're going to look at, we are going to send it April 10 census, and then we're going to show also how to break it up into more categories or reduce the number of categories by using the keyword breaks. This is the output from the very first command, the command you can see at the bottom where it says HIST US state pops, $, to indicate a column, and then the column name April 10 census. The y-axis is going to be the frequencies, how often the data occurs, and the x-axis is going to represent the quantities. Here, each tick mark up the vertical side goes up by 5 million in population. So what this graph is telling us is that there are nearly 30 states with a population of under 5 million, okay? But you can see how the first 2 bars have majority of the information. So it's kind of overcrowded right there. So how do we get more detail of what's going on right in there? Well, in order to do that, we can use that breaks word, okay? So this histogram is using that second command. You can see how it broke up that crowded portion at the very beginning, okay? You can use this function to alter the categories so that each tick mark on the x-axis is going to be about 2 million per bar. This shape that it's making, how it kind of does this if I connect the tops, it's called a reverse J swoop, okay? Makes sense. A J goes this way, this one swoops that way. It's a reverse J swoop. Starts high, swoops down at the x-axis. Now, is that the best shape? Probably not. But there are a lot of different shapes that your distribution can make. The most common known is a bell curve, but technically a bell curve is a normal distribution. It's a term that was created by Carl Friedrich Gauss. Name might sound a little familiar, right? This graph is a normal distribution rather than a reverse J of the state population. So how do we get this normal distribution. This is the first time we're going to use something called a nested function. So we're going to use a function within a function. So here you can see we use the hist function, right? But what we're sending it is the output from another function. Okay, there is a function called rnorm, all one word, all lowercase, and that function is going to generate the new fake data. Okay, the thing to notice is that the innermost parentheses is going to be run first and then the outermost. So pay attention to where your parentheses are. So this is showing a nice, pretty normal distribution with the highest point in the very center. Now, this graph looks good, but we can make it better. Okay, with R, it is very easy to add titles and to make some of your information that you can see on the histogram better. So we're going to add a better title and a better x-axis label to this histogram. So you can see here the command. This box right here is all one command, as you can see. Okay, here's your rnorm, but see there's a comma here, so you're still within the parentheses of the histogram function. Okay, after you send it the list, you say main equals example of normal distribution, comma. That is going to create that main title at the very top and call the entire graph example of a normal distribution. Okay, so now our title has a nice meaningful title. Then there's another comma and it has xlab equals and another string. Okay, what that's going to do is it creates the x label of the histogram and it's going to give it whatever you put in that string. So here we called it distribution with a mean of blank and a standard deviation of blank. Okay, we know they're not blank. I'm not reading those big numbers. Okay, now again, notice that main equals and x label equals, they go inside the histogram parentheses and not the rnorm parentheses. Okay, rnorm parentheses stop here, your histogram parentheses stop down here. Okay, that's really all there is to visualization of data. So that's the end for today. Lab 3 is the only assignment after today's lecture, but coming up after Thursday, there are 2 assignments and 2 labs. So for the week, you're going to have 2 assignments and 3 labs. Lab 3 is going to have you create a function to do some additional cleaning of a data set. You're going to create some lists of random numbers. We're going to get some descriptive statistics on these random numbers, including creating some histograms. So it should be kind of fun playing with the histogram. As always, if there are any questions, email me and I'm here for you. So happy coding.